So let's start. In previous class, we have already seen what should be the electric flux through passing through a surface when placed in an uniform electric field and when placed in a non-uniform electric field. So let's recap it. If the electric field is uniform, and let's suppose it is making some angle theta, let me fill the ink. So let's suppose this is some surface and this is its area vector, A vector, right? And electric field is making some angle theta. Let's suppose this one is electric field making some angle theta and it is uniform electric field in that way. So this is the electric field passing through this area, uniform electric field, right? Equal spacing, all parallel. So it is making some angle theta. Then we say the total electric field, electric flux passing through this surface, right? Passing through this surface is E vector dot A vector dot product of uniform electric field and area vector, that is E A cos theta, magnitude of electric field, magnitude of area into cos theta. Theta is the angle between electric field and area vector, right? If E will be parallel to A vector, it means in such a way. If E will be in such a way, parallel to A vector, then theta will be 0 degree. So phi is equals to EA cos 0 EA. And if E will be like this, in that way, so E vector and A vector both will be perpendicular, then theta will be 90, E vector and A vector will be perpendicular, theta will be 90, so cos 90 0, 0 into anything 0. So no electric field passes in such condition, right? This is the general formula when we are talking about the uniform electric field. Now, but we have already discussed when placed in non-uniform electric field. So let's suppose this is the same surface. Let's suppose sometimes electric field somewhere here, somewhere here, somewhere here, somewhere here. In that way, electric field in such a way. So what we need to do, whenever electric field will be different all along the surface, so we divide this whole surface into small area element, right? Like this, like this. Let's suppose like this, like this. So, and then this is the electric field. Let's suppose this is E1, E2, E3, E4, right? And so on. Let's suppose I have divided a whole surface into small area element of ds1, ds2, ds3. So let's suppose with respect to E1, this is the area vector ds1. With respect to E2, this is the area vector ds2. With respect to E3, this is the area vector ds3. With respect to E4, this is the area vector ds4. With respect to En, let's suppose this was the nth electric field, then its area vector, let's suppose, is in a different direction, dsn. Theta 1, theta 2, theta 3, different angle, right? So what is the concept for non-uniform electric field? Concept. First, we find the electric flux, small electric flux due to a small element, right? What we need to do to find the total electric flux passing through the given surface, first we divide the whole surface into small area elements. Then the next step, we need to find the small electric flux through a small area element, one of the small area element like ds1, separately. Since electric flux is a scalar quantity, then after finding all the electric flux individually with respect to each individual area element, we will sum or we will add them algebraically, not vector form. Why? Because electric flux is a scalar quantity. So what is our aim here? to find electric flux, small is electric flux due to all of them. So d phi 1 will be E1 dot ds1. Might be if there is the angle theta 1, then you may also write E1 ds1 cos theta 1 in that way, right? Cos theta 2 cos theta 3 in that way, whatever would be the angle. Similarly, you need to find the electric flux passing through this S2 surface, ds2 surface. So how much electric flux should be passing? Because with respect to E2 electric field. So the small electric flux, that means how many number of field lines are passing through ds2 area. That is the meaning of it. So how many number of field lines are passing? How to calculate mathematically? E2 dot ds2. That much number of field lines are passing through a small area element ds2. That is known as the electric flux passing through this ds2 surface. Similarly, how much electric field lines are passing through the small area element ds3? For this, mathematical formula is the electric field associated with this area and its dot product with the area vector, corresponding area vector. So ds3, that means whatever would be the value, it will be the number of electric field lines passing perpendicular to the area element ds3, and this is called its electric flux. So electric flux passing through the third area element ds3 is d phi 3. D phi 3 is E3 dot ds3. Similarly, we will be finding all the area, all the electric flux and electric fluxes, and it would be En dot dsn, right? Then what would be the total electric flux overall passing through? See, E1 electric field is there, E2, E3, E4, En electric fields are there. It means so many number of electric fields would be passing through it, but since each and every electric field is in the different direction with respect to its one of the area vector, that's why, and it is random, that's why we have taken out a small area element differently, and we are going to add them. So it will give us the whole total number of electric field lines passing through this area perpendicularly. That value will be obtaining by doing this procedure. So the phi total, or simply just phi e, will be is equals to d phi 1 plus d phi 2 plus d phi 3 shown up to d phi n. Now, what is the total electric flux now? Phi e or phi total is equals to E1 dot ds1 plus E2. This one is d phi 1, E2 dot ds2 vector, E3 dot ds3 vector, shown En dot dsn vector. That much would be the total electric flux passing through this whole surface when this surface is placed in the non-uniform electric field, right? That much. This is the formula. In short, how we can write it? So we can write the formula in short form. This is the discrete addition. Since I have taken this area, one of them here, here, I divided. If I have divided them in a particular format, but in discrete manner, not continuous manner, then for adding them, I will use the symbol sigma. And sigma is for addition, and I will put a journal value, journal variable I. I means 1, 2, 3, 4, 5, 6. So I will be changing from where to where? Like E is changing from 1, 2, 3, 4, 5, n. So I is changing from I is equals to 1 to I is equals to n. Now wherever the numbers are changing, you need to put the I there. So E1, 2, 3 E is changing, EI dot. S is also changing, DS are also changing, DS1, DS2, DS3, so DSI. This is the short form of this total electric flux passing through this surface when this surface is placed in a non-uniform electric field. Now, if this surface distribution of the surface is divided continuously, what I'm saying right now, this formula is valid for discrete addition. If the whole surface is divided continuously means in continuation like this, in continuation. So that if I'll take any one of them as ds, and if I'll integrate them, I'll add all the ds, then I'll get the whole area of this in that way, right? So what should be the concept for this? I need to select any one of the area element. Let's suppose this is ds, and I need to take what is electric flux, electric field associated with this. And I will be finding the electric flux, small electric flux passing through this small area element ds vector, or simply ds area, ds surface. So d phi will be is equals to E dot ds. E is the electric field associated with this small area element. Now, similarly, I'll be finding all the electric fluxes, small electric fluxes due to all such small area element ds, and what I need to then? I need to add them. But since the distribution or division of area element is continuous, and for continuous sum, we use the symbol what? Integration. So just like that, if I'll say this is for, this formula is valid for discrete addition. And if I'll say, some will say, if the distribution of or division of all the area element is continuous, then what I need to write? Besides using the symbol sigma, I'll be using the symbol integration. Integration of what? E and ds. So in general, I can write either ei dot ds, or in general, E vector dot ds vector. If the surface is closed, then we put the symbol like a small circle on the integration. If this is the integration symbol, if I will make a small circle on it, it means I'm talking about a closed surface. In general, by default, we use the symbol for integration, this one. But specifically, if we'll put this kind of a small circle on it, then it means we are talking about the closed surface area. And if this is the surface area integration, how we'll get to know surface area integration? What is this ds? It is showing the surface area. Then we put it as here, like this. If instead of, let's suppose, if there is some lengthwise electric field integration lengthwise, then we will be using this symbol L. If this is volume wise, we'll be using symbol V in that way. This one for closed surface, and S for surface area, L for length, V for volume wise. So we have the general formula. Most general formula is integration of E vector dot ds vector. So this formula is for continuous addition. So most of the time, in 99% situations, we'll be using this formula, E vector dot ds vector. All the things, this formula means general formula can be obtained by using this as well. How we can use it? See, let's suppose I got the formula phi E is equals to what the formula? Close integration of E vector dot ds vector. This is the most general formula, right? Or you can say, after expanding it, you may also write it E ds cos theta. What is theta here? I'll be explaining here. Let's suppose this is the whole surface. This one is the whole surface. And I have taken one of the area ds here. So this is the ds, which is in the same direction of area vector A vector, right? This was the area vector. And if I have taken a small area element here, or if you want to take another, let's suppose I'm taking here, this one is ds. So this ds vector is here, and uniform electric fields are in that way. These are E, making an angle theta, just like that. I'm obtaining this formula by this. Then what I need to write? E dot ds will be the d phi. D phi is equals to E dot ds, and I have expanded it E ds cos theta. Since electric field, now it's the magnitude, And we know that if we are talking about if electric field is uniform, if electric field is uniform, that means what? Its value, magnitude value is constant everywhere. Then whatever things are constant, we can take those constant things outside to the integration. It means we can take E outside of the integration. It means what? Phi E will become E integration of ds cos theta, right? So ds cos theta, right? Cos theta, theta is also same. Can I write cos theta also outside? Because theta is everywhere. See, this is theta, this is theta. So cos theta outside. And this is inside only ds. Why only ds? Ds, why not constant? Because we have divided the whole surface into ds, 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 ds area element continuously. So it means ds is variable only. Now, if what is the meaning, wording meaning of integration of ds? Always remember, keep it in mind. In mind, what you need to read this. Integration of ds is the mathematical term. What is the meaning, actual meaning, wording meaning? It means sum of all the small area elements. And if I'll add them all the area elements, what I will get it? Total area. Integration of ds is giving us what? ds, 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 ds. If I'll adding all the ds together, what I will get? The whole area A. Whole area A. So integration of ds will be giving us what? E cos theta into A. And we got the formula EA cos theta, phi E. So that's how we get the formula for uniform electric field E dot A. So most general formula is this one. It is just like that formula which we used in grade 11 for work done. See, for uniform electric, for constant force, the work done is taken or written to be F vector dot S vector. But for non-uniform forces, we write the formula in general this one, integration of dW or integration of F dot ds. See, so we can take F outside only and only whenever F will be constant. So if F is variable, F is taken inside only. W is equals to F dot ds. In the same way, phi is associated. If the electric field is not uniform, you can't take outside to the integration. It should be kept inside the integration. So phi is equals to most general formula integration of E dot ds. And if E will be constant, it will become outside. And even theta is 0, it means if I'll be taking such kind of surfaces where E and area vector will be parallel, then here itself cos theta would be taken out. Cos 0 degree is 1. So we'll be getting only EDS, right? Integration of EDS, cos 0, 1. E is constant taken outside E. And integration of ds will give us total area. So we will get EA. Then, so that's how we need to learn. See, this does the analogy in between. Work done for constant force, work done for variable force. Electric flux for constant electric field, electric flux for variable electric field or non-uniform electric field. How many of you got the concept, the whole concept now?